Okay, hello, mathematicians out there. Um, this is another day of review. I'm calling it Derivative Concepts 2. Derivative Concepts number 2, or set 2, because we've already did the differential, or these are, wait, implicitly, differentiate with implicit. We did a lot of free response. You should do some extras. I haven't gone over any more related rates. I want to see how you guys do on the end of the packet that had the test at the end, because you've done related rates with cons as well. So I'm taking us all the way to right here, the 36. That's where we're using the first and second derivatives of a function as characteristics of what's happening to a function. So this is the test you were left already. You should have been started that maybe, or this in the weekend, or hopefully if this is Monday for you, hopefully you did it over the weekend. So we're gonna go here. So as I turn the page, you will see that it looks like this homework. I'm skipping all the lecture to it. Just gonna jump right to some problems. All right. So we've got a rational function. For that function, I don't have to read it to you. We want to determine any open intervals for which the function is increasing or decreasing. And he also wants to define extrema. Show your analysis and explain your reasoning. You get a lot of points for showing the analysis and explaining. If you were to just use a calculator, assuming it was calculator active, I don't think this would be calculator active. I think this would be calculator inactive, which, since you're taking the paper pencil test this year, there will be a section that's pure calculator and a section that's no calculator allowed. As I've always said, you need to try hard not to pick up the calculator. All right, so what do I do to determine intervals of increasing and decreasing, let alone max and min? You do the derivative. So this is a quotient, so we're going to start out with, make some extra room for me. You start out just doing the derivative, and that'll be worth points when you at least get the derivative done. So the bottom times the derivative of the top, 2x minus 3. Then we have to subtract the top, because I have not done the derivative of that yet. I mean, I have done the derivative of the top, but I haven't done the function x squared minus 3x minus 4, times the derivative of the bottom, which is just a plain 1. So if you want to put it just to hold your thought, fine. All over the bottom squared. So we do have to simplify this because it's hard to work with it if it's not simplified. Now, technically, if you were to stop right there, you probably got a point on a free response problem because you did do the derivative correctly. But you won't be able to get the rest of the points because you need it to be simplified. So if I square this binomial, it looks like it turns into 2x squared minus 3x minus 4x. I'm going to write a 5. Wait, was it minus? Yeah, it was minus 3x minus 4x. That's 7x minus, I can't add. And then plus 6. Now I got to be careful that I distribute that minus straight through. And so minus an x squared plus a 3x. And then it looks to me like it's going to be a plus a 4. And the whole thing is still over. I'm not gonna multiply the bottom out. That usually never helps. I will if I have to in the future, but right now I don't think it's going to help. So simplify one more time just for giggles. You got a 2x squared minus an x squared. That leaves me an x squared. That gets rid of these two. You got a negative 7x and you got a plus 3x. I believe that gives me a minus 4x. I got a plus 6 and a plus 4. That's a plus 10. And then the only reason that I keep this is x minus 3 squared is because if I factor that top and I have an x minus 3 in it, then I could cancel that. But it doesn't look like I'm going to have x minus 3 in it. So once you have that derivative as simplified as you can, it's not that you get any more points for it, because you already had the derivative right up here, but you had to get this right. Now, I would label this again just so that the author knows, the readers who are grading your papers know you did that. There's two things you got to pay attention to this. Is you have a numerator, and when the numerator, when h prime of x is set equal to 0, all we care about is that numerator. But when the denominator is set equal to 0, that means h prime of x is undefined at x equals to, is it a 3 or a 2? I wrote it wrong here. It's a 2, it's a 2, it's a 2. Thank you for somebody yelling at me, I'm sure it was. X minus 2. And so at x equals to 2. So that's important to think about. So now we've got some pretty good information here. So what I'm going to take this and find my critical numbers. Because if we take our, well, I didn't even say set equal to 0, so I'm going to set that equal to 0. X squared minus 4x plus 10 equals to 0. And you might even want to let the reader know what you're doing. I'm finding critical numbers. And then this is factorable. Both are still equal to 0. Looks to me like it's going to be, it can't be a 5 and a 2. Can it be a 5 and a 2? Did I add right? Did I add wrong? Does it factor? Doesn't look at factors. I'm just curious. Maybe there are no real number solutions. How would I check that to see if there's going to be like square roots or something? Do simply just check the discriminant. You can do that in your head. You can do it in your head. You can check the discriminant. What's underneath the square root when you do the square root of b squared minus 4ac? That inside has to be greater than or equal to 0. If it's less than 0, then it's imaginary. So I'm just going to check that because I don't know if I made a mistake or not. And I'm not using a calculator. So b squared would be 16. So my discriminant is 16 minus 4 times 1 times 10. 16 minus 40 is definitely less than 0. So you know what? There are no, I'm going to write that out, no real critical numbers. Now that's a dirty trick. That doesn't happen very often. However, there is, I shouldn't say that. Let me erase that because that's not true. Well, I could have left that. I could have said there are no real critical numbers that makes h prime of x equal to 0. But however, right here, where your denominator is undefined, where the derivative is undefined, that is a critical number. So I'm going to say the only critical number I have is x equals to 2. So what do? We make our table. Remember how we do that? And we're checking some x's, and then we're going to plug those x's into the derivative was h. You're going to plug that x into h prime. And here's 2. And we know for a fact that it's undefined. So I know that to be true, but that just means there could be some vertical line there or a sharp turn or something like that, remember? So I want to know what's happening on each side because he is asking about increasing and decreasing. So I'm going to take any number I want that's less than 2, and probably an easy would just be like a 0. And then any number greater than 2, I can take a 5. It doesn't really matter because whatever I choose, the answer will be the same. So I go back to my derivative. And it's a good idea to use the more simplified part. And let's plug in a 0. And I'm going to do it in my head. Hopefully I get it right. I might make a little scratch note here. When x is equal to 0, h prime of 0 is, I'd say I might do some scratch. 0 minus 0 plus 10, that's 10. 0 minus 3 is a negative 3, squared is 9, 10 ninths. Well, what do I care that it's 10 ninths? Not really. I care that's positive 10 ninths. So I go over here, I'm going to put positive. Now I'm going to try that 5. What did I put? I put a 5 or a 6. I don't know now what I wrote. I thought I said 5, but I'm going to go back to the 5 now. So I'm going to check h prime of 5. And if you can do it in your head, you're a lot better than me. And remember, all I really care about is it going to be positive or negative. So let's not work that hard. At the bottom, no matter what I put in, it's going to be squared. So I know the bottom is going to be positive. Let's check the top. Now I might want to plug it in. 25 minus 20 plus 10. Well, 25 minus 20 is still a 5, and 5 plus 10 is still 15, so that's a positive. So I know that on the right side, it's also positive. So here's what I envision the function to probably look like. It's increasing forever and ever and ever and ever and ever. Something happens here at 2. Something happens here at 2. And then it's increasing, 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 increasing after 2 again. So not really sure. I'd have to look at a deeper picture of what's happening. It's a weird function up here. It doesn't look like it gets removed, so it doesn't look like it would be, what should I call it, removable point of discontinuity. Because if I factor the top with an x minus 2 hoping to remove it, I could have another x and a 2 here. And the only way it won't. I have to have a 2 times 2 to get a 4. So I'd have to have them both positive, both negative. If I put them both negative, that gives me positive 4. If I put one negative and one positive, I can't get a 4. I could try. Well, so I'm not going to be able to cancel that out, is what I'm saying. So whatever's happening, it's not a whole. It's not a whole. It has to be some sort of asymptotic. It could do this. It could do this. I'm just playing. I don't know. I know it's not a whole because a whole means you removed it. So I'm just guessing that there's probably a vertical asymptote there. Okay, and if I'm wrong, I'm wrong. It doesn't really matter because the whole question is, I need to talk about my intervals of increasing and decreasing. So you have to write a paragraph. Since h, I can talk about it in terms of h of x or h prime. I'm going to say since h prime of x never changes signs, we know there is no relative max or min. Because I'd have to do like it was increasing and then it was decreasing. Well, it never did that. It never switched. It was increasing, then it's still increasing because something's funky's happening here. Something's crazy. So there's no max or mins. He was asking, how about my intervals of increasing and decreasing? I'm going to say h of x is increasing on the interval negative infinity to 2. And I know it's increasing, but I don't know what's happening at 2. It's undefined, so I got to make sure it's open. And it picks back up from 2 to infinity. And I got to say why. Because h prime of x was greater than 0. Okay? Now, Well, I can say since h h prime of x, I can say that since h prime of x is never less than 0, h of x never decreases. And I think I've answered everything he said. This could have been like a two-part free response problem. It's a lot in there. And what I would ask you to do is when you get done, they're going to find your work and they're going to see it. They're not grading you on your work, but they are going to want this work matches up everything I've done here. This table's not sufficient enough. You have to really, these two paragraphs are having to be related to what you have written over here. You know, how you did your critical numbers, how you used the critical numbers in a sign test. So that was, for one homework problem, that was a lot. Another one, we got, well, we're just going to do the same kind of stuff. He wants to know where it's increasing, max or min, show your work and justify your reasoning. So I have a feeling I may run out of room on this one. So maybe what I might do is cheat and try to copy it to a clean paper. Let's see if I remember how to do it. I'm going to edit, copy. Oh, okay, that didn't do what I wanted to do. Try it again. Well, let me just copy that. Darn it. Well, that's depressing. I thought I could. I've done it before. Oh well. Guess what? I'm gonna deal with it. If well, at least it's factored. Oh wait, it's also f prime. So he's asking what's happening to f of x, increasing, decreasing, and or reaching a relative max or min. Show your work. Okay, since I already have the derivative, thank goodness. I just got to worry about my critical numbers again. F prime of x equals to 0. So literally, I don't even have to write it out again. It's already factored. I can say x minus 1 squared equals to 0, or x minus 2 is equal to 0, or x minus 4 is equal to 0. So my critical numbers occur, and there's no denominator, so there's no undefined. If I square root both sides, I still have a 0. X is going to be, because plus or minus 0 is still 0. X could be 1. X could be 2. X could be 4. We play the same game, guys. We play the same game. We make our sign chart. I'm plugging in some x's, and I'm checking f prime of x at those. And I put in my critical numbers, where a 1, that's where the derivative was 0, or a 2, that's where the derivative is 0, or a 4, that's where the derivative is 0. And if you recall, I can make up any number I want. He's not giving me any domain. So I'm just going to go 0 over here. I'm going to do a 1.5 over here. I'll do a 3 here. Okay. All I really care about is the signs. So if I plug in the 0, that gives me a negative 1 squared. That's going to give me a 1 in my little scratch work here. If I put a 0 here, that gives me a negative 2. If I put a 0 here, it gives me a negative 4. So a 1 times a negative is still going to be a positive. So I know I'm dealing with at least a positive on the numerator. And, oh wait, that's all there is. It's always positive. Never mind. That's it. There's just a numerator. If I plug in the 1.5, let's see what happens with 1.5. Well, 1.5 minus 1 is still a 0.5, and you square it, it's still a positive, right? Then I have a 1.5 minus 2. Unfortunately, that's negative. So I have that times a negative. Then I have a 1.5 minus 4. That's also times a negative. But a positive times a negative, that's still positive. So I'm not trying to work too hard if I can help it. All right, I need to try. Oh, I missed something too. I'll get it to in a minute. 3. 3 minus 1 is positive. 3 minus 2 is positive. And then 3 minus 4 is negative. So positive times a positive, that one's going to be negative. But I forgot to put another number on the other side. And I remembered we were doing these before. Some of you kept forgetting to check the outside and inside of these critical numbers. So I need to put another number, 5. I'll put a 5, see what happens. So that's going to give me a positive. That's going to be a positive. It's going to be a positive. So that also becomes positive. So using this chart, I have an idea what the picture looks like. It's 0, so it's increasing, plateaus to a max, but after it plateaus, it increases again. So it does give me a max right here. And then after it maxed out, it doesn't decrease, it just starts increasing again. And it maxes out again, so I have another one there. And after this max, then it does go down because of this negative. And it goes down, and then it maxes out again, and I have a minimum. Then it's going up again. You see? So that's what that picture looks like. That goes down forever, and this is going to go up for, that's a pretty good picture. So what does it mean? It means increasing. That means, is that a max or a min? No, neither max or min, because the derivative did not change signs. Then here, it was increasing and became 0. Well, where was it at? Increasing 0, increasing 0, then it's decreasing. So this 0 would be a max because it did go from increasing to decreasing. Okay, you see it? And so at the next 0, it went from decreasing to increasing. So that did this. So that's a min. So I have neither, I have a max, and I have a min. I have increasing, I have increasing. I have decreasing, I have increasing. So now we got to write that whole paragraph. It's a lot of work. Let's start with the increasings and decreasings. I'm going to say f of x is increasing on the intervals from negative infinity. And I have to take a pause at that 1. I have to take a pause at that critical number because it's not doing anything there. It's not 0, so it's not like it leveled off, and it's not increasing there either. So I have to pause, but then I pick it up where I pick it up, I'm saying union, from 1 to the next critical number was 2. I can also say it was increasing. I can go union from, where was it going to be? From 4 on, 4 to infinity, because f prime of x was greater than 0. Then what was my interval of decreasing? That was from 2 to 4, was decreasing until I get to the 4 again. So I can say f of x is decreasing on the interval 2 to 4. And you got to say, because f prime of x less than 0. Now I have to talk about the relative max or mins. There's one of each. There's a f of x has a relative. The first one was a max at x equals to 2. It has to be a critical number because f prime of x changed signs from, it went from, if it's a max, it went from positive to negative. Let's see, did it do that? Yeah. It was positive here, and it was positive here in this interval until it gets to the 0 here. And that's why I called it a max, because it went up, then it went back down. It went down to negative. And then I'm going to say f of x has a relative min at x equals to 4, because that's where it went from negative to positive, remember? At x equals 4, because you got to say f prime of x changed from, watch this, you could say from less, what was it? It was less than 0, changed from less than 0 to greater than 0. It all means the same. Okay. Woo, that's a lot of writing. Okay. I'm going to move on because I want to cover something else. Everybody keeps saying, what problem do I do? All of them. You know, if you don't pay attention to what I say in the lecture, do everything then. But definitely I'm starring this one. What's on the next page? Identify the intervals where the function is concave up and concave down. Okay, so what does that take? This is all about the second derivative. So thank God he's given me one derivative already. So g double prime of x. I'm going to rewrite that to make it easy to use. 8x minus x squared to the 1/2 power. So the second derivative, multiply the power, 1/2, 8x minus x squared. And if you saw Mark and Verge, they were having a stamp called the chain rule stamp. Every time they got a chain rule, they said, chain rule, to make it a big deal. And they would stamp that problem as chain rule. Well, obviously it's a chain rule because I'm going to take 1 away from the half, and that's a negative 1/2. But then I got to go back in and do the derivative of the inside function, which in this case is 8 minus 2x. So there's your second derivative. Now, if I write it in a more traditional way, you would see it as 8 minus 2x divided by a 2 times the square root of 8x minus x squared. And if I did it right, you could probably cancel out the 2 and make it simpler. So I can make that a 4 minus an x, because I can take this 2 here and divide by a 2, divide by 2, divide by 2. So that's 4 minus x, still over the square root. You didn't have to do that. Sometimes I wouldn't notice it because I'm not quick enough, but I saw that. So what do I do to find concavity? Well, you check concavity by setting g double prime of x equals to 0 and find critical numbers. Okay, so here goes. I'm going to take my second derivative, 4 minus x over the square root of 8x minus x squared. Set that equal to 0. And before I even do any work, you do agree that there is a place possibly where the derivative could be 0. So you need to check this denominator before I even multiply both sides by it. Let's check for an undefined second derivative. Let's check. I'm going to take my square root of 8x minus x squared, set it equal to 0. That gives me 8x minus x squared equals to 0. That means I could factor out an 8x. That gives me a 1 minus an x, still equals to 0. That gives me x could be 0 or x could be 1. Those are critical numbers, you mathematicians. So I need to use those in my sign chart. So now, let's move on. Multiply both sides by that denominator. I know you could do it in your head, but I want to show you that that's what you're really doing. It's why I don't care about that denominator too much, except for the fact to check for this. I needed to check for those. So now I have 4 minus x equals to 0. That gives me x could be a 4. That's a critical number. So you got this critical number, and this critical number. We make a sign chart. We plug in some x's. We're going to take those x's, we're going to plug them into, what was the function called? G? G double prime of x. My critical numbers were, I'll put them in order. I have a 0, I have a 1, I have a 4. Leave some room, 0, 1, and 4. I'm going to use a different color so you understand what I'm saying here. 0 was where it was undefined. 1 is where it was undefined. 4 is where it's defined. That's where the second derivative was 0. So I need numbers on every side, just like we did on the other problem. I'm going to do something simple. Negative 1, 1/2, and a 2, and a 5 again. Okay? Those red numbers are what I plug in to see what's happening. Find the simplest version of your second derivative. I'm going to go right to here. I'm going to use this. It's staring at me. Again, I only care about signs. If I plug in a negative 1, the bottom has to come out positive, taking the square root, and I'll prove it to you. A negative 1 squared is 1. 8 times 1 is 8. 8 minus 1 is 7. Square root of 7, it's positive down there. The top, 4 minus 1 becomes a 5. So it's also positive. Therefore, what do I say about positive? This means it's concave up. It looks like this. Okay? Then something happens where the second derivative doesn't exist. Okay? And I'm here at a half. So let's see what happens here. At the bottom, again, a half squared is a fourth, and 8 times a half is 4, and 4 minus a fourth is still positive. So the bottom is still going to be positive. But the top, let's see, 4 minus a half, it's still positive. So it's still, I hope it's still concave up. And I've been wrong before. I definitely have been wrong before. So where am I at here? I have a concave up, I said, or I thought I was concave up. I have a concave up here, positive. Wondering about my negative value. Did I do that mathematics right? Can someone double check? Not that you can tell me. The bottom, let's make sure if I plug in that negative 2. I can. I'm going to run with it, but there might be a reason why we don't use that left side. I can't remember. I'm going to run with it for now. Okay, I've got a concave up here. Let's plug in the 2. Let's plug in the 2. 2, let's see, 4 minus 2 is positive. 16 minus 4 is positive. Square root still positive. Wait, I thought I was supposed to get a negative on that one. I thought. Go back and let's look at my solving down here. And I apologize if I didn't solve it right. The denominator. Do I really have the 0 and the 1? See, I think I have a 0, 1, and a 4. It was 8x, 8x minus x squared set equal to 0. 8x minus x squared equals to 0. Why did I factor out an 8x? That was ridiculous. I should only have factored out, what color do I have here? I should have only factored out an x. That would have left an 8 minus x. Yeah, I don't have a 0. Oh yeah, I do have a 0. I do have x is 0. I don't have a 1. I have an x equals to 8. Oh man, all that thinking. So I gotta go back up here. I did have the 0. I didn't have the 1. Did I have the 4 still? Yeah, I still have the 4. Okay, sorry guys. I'll give your money back. I'll give your money back. I was trying to remember if I had that many. I didn't remember that. Okay, I still believe I had the 0. And then my other one was a 4. Then it's an 8. Okay, so the other numbers, no harm. At least I caught it. It wasn't looking right. The 4 was where the derivative was undefined. No, it was 0. And the 8 was an undefined. Okay, so the numbers I'm going to pick in the middle will be, let's see, I still got that one's fine. I can pick anything here. 1's easy, 5's easy, that's in here. And bigger than 8 is a 9 or a 10, so I'll put a 10. All right, now let's put in the 1. I'm sorry. Let's do the 1 now. Second derivative. 4 minus 1 is 3. That's positive. 8 minus 1, that's going to be positive. So positive over positive means it's going to be a positive, right? So it's concave up. If I plug in the 5, 4 minus 5, that's negative. The top is negative. So make sure I put that. Oh, I'm not writing. Negative over. And it should be a positive because you can't get a square root. You can't get a negative number, but just for fun, I'm plugging in the 5. What's happening there? 40 minus 25, it's still positive. So that's going to be concave down. Concave down. So we have 2 concave ups, supposedly. I'm still wondering if there's something weird happening over on this side, but I don't have time to babysit it. I could have a mistake there, but what happened at the 10? Where did I get the 10 from? Oh, this is a 5 from before. Okay, I know I was confused. That was the number after the 8 because it was undefined it there. So I got to plug in the 10. And I have a feeling that's what's going to happen. 10. 4 minus 10 is negative. And 80, right here. 80 minus 100. What's happening? Yeah. Oh, the square root. I know what's funny. There's something else we could have checked for, that denominator being a square root. We know for a fact that the square root of 8x minus x squared always has to be bigger than 0. So when you solve this one to see your possible domain restrictions, you get 8x minus x squared can still be greater than or equal to 0. And then when I solve this, by factoring out, you remember when I factored out and I got that other number? But if I factor out that, now I remember, x, 8 minus x, has to be greater than or equal to 0. So the 0 over here that I got, I can go back, I knew it was weird. I did this work, but it doesn't count because x has to be bigger or equal to 0. Well, I did say or equal. Can't be. Yeah, it can be. So I'm not going to be able to go farther left. Have to be greater than or equal to 0. Even though it's still undefined because it's in the denominator, but it can't go this way, that's for sure. And here, look at here. If 8 minus x has to be bigger than 0, then if I minus 8, that negative x greater than 0, if I divide by that negative, x has to be less than That's supposed to be an 8. Wait, where is it? That's a 0. That's supposed to be an 8. X has to be, it was a negative 8, wasn't it? Yeah, I took negative x has to be greater than a negative 8. And if I divide both sides by negative, it switches the sign. It has to be less than 8. So right here, it's kind of like another boundary. It doesn't matter what's happening there. Wow, what a lot of analysis. I'll be honest, I don't think you'll ever get nothing like that on the AP test. That's too many, there's too many red flags there. But let's talk about our concavity. All right. Since G double prime of X is, what do I have? I have a concave up and a concave down, is greater than 0 from, I'm going to go 0 to 4. I'm going to say G of X is concave up. Why? Since the second derivative was greater than 0. Since G double prime of X was less than 0, where was it less than 0? It was right here, because negative over a positive is less than 0 from 4 to 8. I'm going to say G of X is concave down. There's something else I want you to remember. Since your concavity went from up to down, this is what happened. Concave up, concave down. What do we call what happened here if it was change of concavity? You better say something. You better say there is a point of inflection at x equals to, now that's going to be the hard part. What is x equal to? Where did that happen at? Happened right here, 4. It happened at that critical number. It's a critical number where the concavity changed. So at x equals to 4 because concavity changed from concave up to concave down. So that's a lot. That's a mouthful. I want to do another one, or should I make you do it? Let's do it. We're doing concavities again. Okay, whenever you do concavities, you're also doing points of inflection. So this time, this one, he gave us the derivative. He gave us a derivative. This one didn't give me a derivative. So you're stuck. So I got to go G prime of X, product rule. The first times the derivative of e to the u, e to the 2x, is always e to the u times the derivative of u, so that's times 2, plus the second, e to the 2x, times the derivative of x, which is 1. So if you want to put it, fine. Now, how can I clean this up? Let's see. I got a 2x e to the 2x plus e to the 2x. I could probably factor out an e to the 2x since they both have one. So I'll factor it out. E to the 2x. You always want to factor. That gives me a 2x plus a 1. And that's just first derivative. I got to do the second derivative. Bummer. G double prime of x will be the first, which is, this is the first, and this is the second. E to the 2x times the derivative of the second. Well, that's easy. 2. Plus the second, 2x plus 1 times the derivative of e to the 2x, which is 2e to the 2x, because it's e to the u times the derivative of u, so there it is. Anything pretty there? Let's see. I could factor out an e to the 2x and see what happens. Factor out e to the 2x again, and that gives me a 2 plus another 2 times this stuff in here. So technically, it was a 2x times 2 and a 2x times 1. So why don't I call that a 4x plus a 2? Can you clean that up a little more? Even though, yeah, I think I can. I can say this is still equal to e to the 2x times, how about a 4 plus 4x? Do you like that? Do you? Oh, huh. Now I can factor out a 4. 4e to the 2x. Why didn't you say so? 1 plus x. You don't have to do that, but set it equal to 0 because where the second derivative is equal to 0, I found my critical numbers. There's no x is undefined. X can be anything for an exponential function. So I say 4e to the 2x could be equal to 0, or 1 plus x could be equal to 0. E to the 2x could be 0 divided by 4, that's 0. And just in case you forgot what your pre-calculus teacher taught you, e to the 2x looks something like that. It's asymptotic. It can never cross the x-axis unless there's a negative in front. Okay? Well, it doesn't have a negative in front. So there's no x's, no x values. So you can just ignore that. But over here, x could be a negative 1. All that work for one critical number? Well, so we got my x, and we're still doing, these were still g's, weren't they? G double prime. Only one critical number, a 1. So you're forced to smaller than a 1. You'd be crazy to use a negative 10. Why don't you pick something small like a negative 2? Or pick a 0. Probably that would also work. And I'm going to pick a 3 over here. So I know at 1, the second derivative was 0. So let's see, find the easiest form of the second derivative. I think I'm gonna use this one right here. I'm gonna use 4e to the 2x 1 plus x. That's the easiest form of g double prime. So I'm gonna plug my negative 2 in. See what happens. I gotta show the work. At x is a negative 2, here goes. 4e to the negative 4 times 1 plus a negative 4 is, let's see, do you realize that really means 4 over e to the 4th times a negative 3? Well, e to the 4th is a positive number, and that's a negative 12. So I know it's negative. That's all I care. That's all I care. Negative. And the 3, let's see, what did I do that for? At x is 3. I have to write it out. 4e to the 6 times 4, or 1 plus 4. Yeah, 1 plus, no. 1 plus x, 1 plus 3, that's 4. 4. Well, that's not very exciting. That's just a big positive number, I think, right? It's positive. So I go positive. What does this mean? 3 things, guys. 3 things. Concave down, concave up, and a point of inflection at 0. So let's write my paragraph. G of x is concave down from negative infinity to 1 because g prime of x, double prime of x, is less than 0. G of x is concave, C-O-N-C-A-V-E, concave up from 0 to infinity. Because why? G double prime of x was greater than 0. And while I'm at it, there is a point of inflection at x equals to, what was my number? 1. Since at x equals to 1, concavity changes. Okay, so second derivative test to test local extrema. So you can use the second derivative test to test extrema. Here's the logic. If you have a function, and it has, obviously, if I look at this, I have a relative max. Here I have a relative min. Here I have another relative max. What do I know about the concavity? Here was concave down. When it's concave down, the extrema has to be a max because it sits on top of a hill. This, from whatever the inflection points are, is concave up, and there exists a relative min. The relative min sits at the bottom of concave up. Again, concave down, relative max lives there. Where do I get these possible max and mins? They come from your first derivative set equal to 0, and you get x equals to C1, C2, and C3. C2 and C3. Then we take those C1, C2, C3, and we plug them into the second derivative and see what we get. Well, if I plug in C1 into the second derivative, since it's concave down, it's going to give me a positive number. Wait, because it was a max. Did I say that right? Let's try it and see if it works. So if we get a second derivative plugging into a C, and we get a positive number, it's going to be a min. If we get a second derivative, plug in that C, and we get a negative number, it's going to be a maximum. Because concave down is negative. So if you get that's a negative second derivative. So if you get less than 0 second derivative, it has to be a max. If you get a second derivative, since it's concave up, it's going to be a positive second derivative, meaning it's a minimum. You got to look at the picture and see. So as I work out this first one, and he hasn't done any work for me. So g prime of x is 3 minus 3x squared plus 0. G double prime of x is going to just be a negative 6x. Now, what I need to do from here, and I could have done it, well, I could have done it first, so pretend I didn't do the second derivative yet. let's take care of that first derivative. Let's set this equal to 0 right now and get the critical numbers, okay? My critical numbers. So I set that equal to 0, and I get negative 3x squared is a negative 3, x squared is a 1, x is plus or minus 1. So there are my two critical numbers. I have x equals 1 and x equals a negative 1. Now, this is where I need to do the second derivative, which I did a minute ago. It's relatively simple. It was a negative 6x. I take that second derivative and I test each of those critical numbers. G double prime of 1 gives me a negative 6. Well, that meant the concavity was concave down. So if your concave is down, then this x equals to a 1 right here, a 1, had to be a max. So we say g of x has a relative max at x equals to 1 since g double prime of 1 is less than 0. So now let's check the g double prime at the negative 1. That's going to give me a negative 6 times negative 1. That's a 6. That's greater than 0. This was less than 0. Greater than 0 means it's be a concave up. Looks like that. So what's living at the bottom of concave up here? Right here? This is x equals to a negative 1, living right here. So what am I going to say? I'm going to say g of x has a relative minimum at x equals a negative 1 since g double prime of a negative 1 was greater than 0. Now, we may not have hit that very hard in the college textbook because they don't care to analyze graphs that much. They just do a lot of mechanics. So I tell you, you can be an excellent calculus student, but you have to still work hard to pass the AP exam. All right, let's do h prime. H prime of x, 3x squared plus 6x. Find the critical numbers. Let's find them, critical numbers. How do I do that? I set this thing equal to 0. There's only two terms, so I can just factor out the common, 3x, leaving an x, plus 2. Still equal to 0. X can be 0, x can be a negative 2. So there are my critical numbers. X equals 0, x equals a negative 2. Find my second derivative now. This is just another way of doing extrema. H double prime of x now is equal to 6x plus 6. I don't set it equal to 0. I check my critical numbers from h prime of x. That's what I'm doing here. So I'm going to do h double prime of a 0. That gives me 6 times 0 plus 6. That gives me 6. So I know at x is 0, the function was h of x is concave up because this is positive. So it looks like this. So living at the bottom of concave up is a minimum. And now check h double prime of, what was the other critical number? 2. That's going to give me 6 times 2 plus 6. That's 12 plus 6, that's 18, which is also greater than 0, like we had their problem. So it also is concave up, if I did the math right, which I don't think I did it wrong, but I could have. Did I? What was my function? Was x cubed plus 3x squared minus 2? x cubed plus 3x squared plus 6x. Pull out my numbers. I got 3x factored out of x plus 2. Oh, that's a negative 2. Oh my goodness. Right here, I see it. I wasn't expecting 2 concave up. Sorry. That's a 6 times a negative 2, giving me a negative 12 plus 6. That's a negative 6. Sorry. Which is less than 0. Which means it was concave down. I wasn't expecting 2 same concavities. So it was concave down. And what lives on top of concave down when x equals a negative 2? A max. So you got to write that out. Let's start with the function. H of x has a relative minimum at x equals to 0 since h double prime of 0 was greater than 0. H of x has a relative max at x equals to a negative 2 since h double prime of a negative 2 was greater than 0. And since they know where you got those numbers from, they know you got them from the first derivative. You want to repeat where you got them from? You can. Highlighted, I did all those with you, so you should upload those as notes. All right, I am going to call it enough lecture. Read my lips. Homework, day 47. Let's see, what are we doing here? We're using a table to find decreasing to the following intervals. So you're looking at a graph. Some of these are conceptual, so that they're not as easy. What's on there? 1 page. So you got 3 problems. So the next page starts something else. I highlighted it. Do these 3. Page. Oh, that was it. Which I wanted to do, but I guess I'll do this. I'll do this over the weekend and give you another lesson. Okay? This will be set 3. All right? Please don't ask me what do I have to do.